Hello viewers, welcome to the second part of video lecture. In this video, we are derive formula for power requirement of vehicle. Let us start. Suppose this is your engine and the torque produced inside this engine is Te. This engine is connected to your transmission, gear transmission, and the ratio which you provide is GT. After that, this is connected to your rear axle, and the gear ratio for rear axle is denoted by GR. And the last, this will move to your flywheel. As we discussed earlier, that gear ratio, if the gear ratio is high, then power is high, but the speed of vehicle is less. So this Te move in the directions and treat with gear ratio of transmission, then it will treat with the gear ratio of rear axle, and finally it reach here at flywheel, and the torque generated or the torque which is used as an output is termed as torque at rear axle. So torque at rear axle is directly proportional to torque at engine. To remove this proportional, we introduce our efficiency, overall efficiency, while this torque moving from engine to your flywheel. There is 2 gear ratio which will also include, because from the equation first, gear ratio is directly proportional to your power. This is your equation first and this is your equation second. So finally, on combination of equation first and second, torque at rear axle is equal to torque produced by engine multiplied by gear ratio of rear axle multiplied by gear ratio of transmission, and the last one is the transmission losses, a transmission efficiency, and this efficiency K is overall efficiency or transmission efficiency. So this is your formula number 1, from where you can find your torque at rear axle with the help of gear ratios and torque produced by engine. The efficiency is related to your 0.85 to 9 because the loss, transmission loss, is 10% to 15%. As we take transmission loss 10% to 15%, that's why the efficiency is always less than 1 or less than 100%. So this is the term. The second is, this is a wheel. The radius of wheel is R0, and this wheel is contact to a surface, road surface. But due to deformation of this wheel, the radius which is contact to the road surface is Rw. So in this case, R0 is greater than Rw, or we can say that Rw is lambda R0. This lambda is known as tire deformation factor. This is known as deformation factor, and the value of tire deformation factor is lambda equal to R0 upon Rw. This lambda is suppose this is a tire. This lambda is depend on only the air pressure of tire. So the value of lambda is taken as 0.945 to 0.95 for high pressure, for highly air pressure tied, and lambda is taken as 0.93 to 0.935 for low air pressure. So this is the tire, and the motion of vehicle is in this direction. Hence all the resistance force which affect the power performance of vehicle act in opposite directions. So this is the all the resistance in terms of force. That's why I use this PP. This is the summation of all resistive force which act during the motion of vehicle, and this is the direction of motion. This is the direction of resistive force. And your available torque at flywheel is in this direction, and this value is TR, because this is the ultimate output of your torque which is produced by your engine. Okay, so now how will you relate these terms with this torque? So force multiplied by perpendicular distance is equal to your torque. The formula of torque is force multiplied by radial distance or we can say that this radial distance is perpendicular distance. In this case, the given torque is TR, and this will be equal to your force. Force is your resistive force PP, and the radial distance is taken from the point of contact, not from the top of the tire, because the resistive force is acting with the surface of tire and road. So the distance which is from the contact point is your Rw. So this is your formula number 2. This PP is equal to your rear axle torque divided by Rw. Now come to the next formula by which we are able to calculate our RPM value of engine. In this case, let's talk the output power. Output power. What is the formula of power? Power is nothing, just rate of work done. So work done upon time is equal to your power. And what is the formula of work done? Work done is force into distance which is parallel to this force, not perpendicular to this force. Okay, time. Force into distance upon time. Distance upon time is equal to your velocity. Force into velocity. Please note down that I use small velocity, means the unit of force is Newton and the velocity meter per second. In our case, the resistive force is equal to your TR, and this is a resistive force. So we use this if the velocity of vehicle is small v, means the motion of tire in forward direction with the velocity of small v. So the output power is equal to resistive force multiply this small. Or we can say that this will be equal to capital V. Capital V is the velocity, which unit is kilometer per hour, divided by 3.6, or in short way this will be equal to 0.278 pp into capital V. So this is about your output power. But this formula is not complete here. We will go further. Let's talk about the RPM. For this particular wheel, the radius is Rw, which is the smallest radius as compared to R0. So the RPM of this wheel will be equal to revolution per minute of wheel equal to number of revolution of wheel per minute. Minute is equal to your 60 second. Number of revolutions is calculated as capital N divided by 60. Okay, but when we are talking about the speed, so small v equal to circumference of wheel divided by time, or we can say that this small v is equal to how many revolutions this wheel has been taken for 1 second. So this v is related to this RPM formula is like that: 2 pi r w is the circumference of wheel multiplied by RPM, and RPM in this case is n upon 60. But this n is not calculated by your RPM meter, because in RPM meter of vehicle the n is related to your crankshaft revolution. So how we calculate the crankshaft revolution? We convert, suppose this is your engine in which the small n represent the number of revolution of crankshaft and this is your rear axle on which your wheel is attached, and here is the number of revolution is n. So how we relate these two values? When you're moving from this end in this direction, so you will face some gear ratio which is gt comma gr, as well as overall efficiency, and that overall efficiency is defined by k. In this case we can say that our small n is equal to k g transmission t ratio and g related to your rear axle gear ratio by n. So your velocity will be equal to 2 pi rw n divided by 60 kgt multiplied by gr. So this is your, please note down this formula, and this formula can be written as capital V equal to 0.377 Rw, number of revolution inside the engine, overall efficiency of engine, transmission gear ratio, and rear axle gear ratio. Okay, we already defined our output power. Our output power is like this, small v, and this will be equal to your pp multiplied by 0.377 Rw n divided by 60 kgt gr. So this is your output power. This is your equation number 2. Okay, main equation number 2. Convert this output power into horsepower. So output power into horsepower will be OP, this is kilowatt, divided by 735, or we can say that main equation number 2 divided by 735. So this is all about the today's lecture, where we have find our equation number 2 and our equation number 1. Main equation number 1. In next lecture we are going to deal with the numerical related to these two equations, and one more thing I have to tell you, that this pp is equal to your rolling resistance plus air resistance plus minus your gradient plus minus your inertia and transmission losses, and that transmission losses is 10 to 20%, 25% or 15%, depend on the given data. So thank you for your precious time. Thank you all.